Hi students. Today we're going to talk about land and sea breezes, and I'm going to guide you through some notes. So, if we're thinking about land and sea breezes, I'll write this on the title. Remember, if I write it, you write it. Land and sea breezes. Land and sea breezes. So, the first thing to remember is we have the Earth that has all these different things happening on it. We've got waves and wind and currents, and the first thing we need to remember, and I'm going to draw a little sun here, is that the sun is the source of energy which powers everything. So I'm going to put sun is the source, and this is just to remind us that anything that's happening, any movement that we see in the atmosphere and on the earth, the sun is ultimately the source, and that it moves the winds and currents, and since that's what we're talking about mostly in this unit. And the other thing to remember is that this heating of the Earth's surface is uneven. So it heats unevenly onto the Earth's surface. And this happens kind of in two ways. One is we have an unevenness in on the face of the Earth because we get more direct sunlight at the equator. I'm going to say more direct at equator, EQUA, equator, than at the poles, right? So we have more heat hitting the equator than at the poles. And then we also have this other thing, which you might not be aware of, that surfaces, so this is kind of one thing, we're going to make another note here, that surfaces heat unevenly. And so this is a physical property of matter called specific heat. And you're going to learn, I can't talk and write at the same time. You're going to learn more about this in chemistry. So it's actually called specific heat. You'll learn more about it in chemistry in high school, but I want to introduce this idea to you now. The specific heat, it's a standard that it's basically the measure of how much energy or heat it takes to raise the temperature of a substance 1 degree. So let's see, we'll put how much energy or heat is needed to raise the temperature of a substance. So the specific heat of water is this kind of the standard that we use to compare things to, and the water specific heat is 1 actually. So so the specific heat also tells us, it kind of gives us a sense of basically how the substance holds on to the heat as well, how it holds on to or retains heat as well, because it kind of wants to stay how it is. That's why it takes a lot of energy to say boil water or to raise the temperature of water, and that has to do a lot with what we're talking about now with land and sea breezes. So water has a very high specific heat. So 1 is actually quite high. It has a high specific heat in comparison to other things. And so when we're thinking about the land and the sea, the land, the rock and the earth actually has a lower specific heat. So it warms up. So I'm going to say land warms more easily or quickly. But in the same breath, it also cools more quickly. So it doesn't hold on to that heat in the same way. That's like if you have a piece of dry toast and it's hot right out of the oven, and you have a piece of greasy pizza and it's also the exact same temperature in the oven, and you pull them both out of the oven, then your dry toast is going to cool off a lot more quickly than that hot greasy pizza. So land, dry things cool more quickly, and then water, it it warms more slowly, but it also cools more slowly. So once it is warmed up, it holds on to that. It holds on to that heat. So let's draw some pictures, and we can see how this affects coastal areas. So let's take a look first. I'm going to draw some land and some sea, and you can draw this as well. So imagine that the sun is shining down on our land and our sea all day long. And as the sun is shining, the land is going to warm up more quickly. So this is going to warm. It's going to warm up more. And this is going to warm less, okay, than when we're comparing these two things. So you can imagine this, when the sun's shining, even on a cold day, the pavement or a stone will get warm or hot, and so the sun can warm up that more easily. So when that air over the land warms up, what we see is the air beginning to warm. And remember when we talked about density, that warm air is less dense. So as the air warms, we can say as the air warms, it becomes less dense. And then it rises. So we're going to have a picture here. So the warm air is going to rise, warm air. And it leaves below it an area of low pressure. So I'm going to put an L there with a circle. That's an area of low pressure underneath it. Now, nature abhors a vacuum, doesn't like areas of low pressure. And so areas of higher pressure that's where we're going to get wind. So remember, it's cooler over the sea right now, because the air that's touching the sea right here, the sea hasn't warmed up in the same way. So that cooler air from over the sea is going to blow in toward the land. And this is what we call a sea breeze. And a sea breeze happens generally in the afternoon after the land has heated up all day long on coastal areas. So this is usually in the afternoon. You'll see winds shift in coastal areas where the wind is coming from the sea onto the land, so it's going to bring that cooler air onto the land. Now, what happens when the sun goes down? So let's say the sun goes down. I'm going to draw a little moon right here to indicate it's nighttime. So the sun has gone down now. We're in the same spot. Now remember, during the day the land was quite warm, but the water did collect some heat from the sun as well. But now at night, the water is it holds on to the heat, So it's going to be warmer. But the land, once the air cools off, gets cooler. So it is cooler. So we kind of have the opposite thing happening. We have the the warm air from the sea then is going to go up, and that's going to create an area of low pressure. And then the area of low pressure is filled in from the cooler air from the land. And so this is how we get a land breeze. So we end up having a land breeze in the evening or at night on coastal areas, because the land has cooled off more quickly and the warm air is over the sea comparatively. So the air over the sea is warmer than the air over the land, and so it creates that area of low pressure. And then what we can eventually get to is kind of cycles where when this comes up, as the air drops down in the cool, you end up with an area of high pressure over the land. And so we can end up with kind of a cycle. And so that is all you need to know about land and sea breezes. Remember, a sea breeze tends to be in the afternoon, and we name the breeze according to where it comes from. So a sea breeze comes from the sea, a land breeze comes from the land. The sea breeze is during the day, and the land breeze is during the night.